Hello dear students, today we have the last lecture of chapter 4 and by the end of this lecture you should know how to solve the mathematical question about the titration process. Actually it is the easiest problems to solving in the grade 12 of the chemistry book, which is the practice problem about the titration process. In a prior lecture we've learned that in a titration process we can get the equivalence between the OH and H3O and both chemicals which are chemically equivalent by volume. Then now we have to calculate the unknown concentration. If you remember from the titration process, the last point is the calculating the concentration of the unknown, which we put from the bottom part of the apparatus. Hopefully you remember and just imagine the picture of the titration process. Well, there are two rules to calculating the concentration of unknown. First one, molarity by molarity, and the second one, mole by mole. Okay. Well, we should use a chemical structure, a chemical formula for both chemicals, first of all, because we're going to need the number of H or the number of H3O in the reaction. Well, the number of H in the formula of the acid and the number of OH in the formula of the base. That's why we're going to use their formula. If not, we have to calculate OH and H in case of both concentration and volume are known. Well, we have this question, molarity times to volume times to the number of H plus, this is for acid. Molarity times to volume times to the number of OH, this is related to the base. How we know it relates to the base? Because of the OH. Okay, let's see how it's simple, the practice problem in this section. Okay. Very good, excuse me. Well, now we have this question. Look, suppose that we use 20 milliliters of NaOH with molarity of 5 times to 10 to the negative 3. 5 times to 10 to the negative 3. Required to reach the end point of the titration. Oh, we have the titration process. Please, can you tell me what are the steps of solving questions that related to the titration process? Okay, first of all, write the formula for both chemicals. Okay, chemicals are NaOH and HCl. Well, this is NaOH, and it's HCl. Very good. Now, we have one OH. OH is equal to 1. Good. Volume is equal to 20 milliliter. Good. And molarity is equal to 5 times 10 to the negative 3 molar. Well, teacher, now we have the number of OH, volume, and molarity. So that means it's a standard solution because of the molarity is known. Well, to neutralizing 10 milliliter of HCl, H plus is equal to 1. There's one O, there's one H. Volume is equal to 10 milliliter. Calculate the concentration. Oh, so because of the molarity of HCl is unknown, that means it's a sample and it's a standard solution. We should put NaOH inside of the tube, but HCl from the bottom of the apparatus of the titration process. Good. Now let's write the formula. Well, I don't want to write the equation between them because we know HCl plus NaOH, they can produce NaCl plus H2O. Well, it's simple. Now we have this question, molarity times to volume times to H plus is equal to molarity times to volume times to OH Now we have OH by 1 times 2. Volume is equal to 20 times 2. Molarity is equal to 5 times 10 to the negative 3. Okay, teacher. All of these informations are known. In here, the only missing information is the molarity because of its unknown. And they are given. Volume is equal to 10 milliliter times 2. H plus is equal to 1. Just make a division between them. Use your calculator. So it will be, we have this amount from the below, 10 times to 1 is equal to 10. And in here, from the top, we have 5 times to 10 to the negative 3 times to 20. So it's equal to molar. You know how it's easy to calculating the molarity of the unknown using the equation of the titration process. So first step, we should write formula of both of them, then write the informations of each compound is from there below, and then use the equation. Okay, we have 2 volumes, we have 2 molarities. Well, actually we have 1 molarity, but because of one is given and another one, the second one is unknown, so we suppose that both are, well, this question talks about molarity twice. That's why we should use this equation. Another question. We have a titration process between CaOH by 2. Okay, CaOH by 2. We have CaOH by 2. And HCl. Okay, HCl and CaOH by 2. Just write their information. 20 milliliter and 0.01 molar of CaOH by 2. OH is equal to 2, and volume is equal to 20. Molarity is equal to 0.01. For HCl, H is equal to 1. Volume is equal to 20. Molarity is unknown. So which of them is the standard solution and which of them is a sample which is mean unknown? Of course, HCl is unknown sample, and this is standard solution. So how we can calculate molarity? It's very easy. We have a specified equation for that. Look, molarity times 2 volume times 2 OH, or H doesn't matter because of there's an equal sign between them, so it's not matter to replacing them by each other. So molarity times 2 volume times 2 H plus, it's very easy. Molarity of the acid is equal to, immediately I'll replace the number, I will replace the number from their place. Molarity of the acid is equal to, volume of the acid is 12 times 2, 1, and from the top molarity is equal to 0.01 times 220 times 2, 2. So it's equal to this molar concentration of HCl. So simply that's about the mathematical question of the titration process. It's very easy. The second question is mole by mole. Let's see mole by mole. We can calculate mole of unknown using mole of known. Well, what's about the prior questions? There are molarity of known molarity, and we just turn it into molarity of unknown. So, but in here we have mole by mole, but previously we've learned it molarity by molarity. So mole of unknown times 2H, mole of acid times 2H is equal to mole of base times 2 OH. Let's how it's easy, just like drinking a glass of water. For each of the following acid-base titration combination, determine the number of mole of the first substance listed that would be the chemical equivalence amount of the second substance. Well, this is mean it's a titration, chemical equivalence. It's a titration. Okay, first one, NaOH with 1 mole of HCl. So, look, for the acid, mole times to number of H. For the base, mole times to the number of OH. Okay, mole of acid is equal to 1. H is 1. For the base, we don't have number of mole. OH is equal to 1. Because of there are equal number of H and OH, so their moles will be equal to each other. Because of we have one H and we have one OH. So what's going to happen with the number of mole? So the number of mole will be equal on both sides. All. So look, we have 1 mole of the base also. Okay. Calculate the number of moles of BiOH by 2 that neutralizes 0.2 mole of HF. Teacher, we don't have the volume, we don't have the molarity. Well, this is different question this is different equation if you remember. Mole by mole, we don't need the volume. Even if you have 1 volume, you are not supposed to use the first equation if you have 1 volume. But if we have 2 volumes, then we can use the previous equation. So we know the number of mole of the acid, which is 0.2 times to the number of H, which is 1. About the base, we don't know the number of moles, but the number of OH is equal to 2. So mole is equal to, look, mole is equal to 0.1. Just make your division with your calculator. Hopefully you know how to use your calculator, because of actually I know many of our students still are not familiar to using their calculator. So you're going to face a big problem in the final examination term. Please make your practice. It's very easy. You have to spend only 5 minutes. If you don't know how to use, it's not a shame. Ask to your friend and they can help you how to use your calculator. Especially when we're going to use a scientific notation numbers, such as 1 times 10 to the negative 10 divided by 1 times 10 to the negative 3, for example. So using calculator is very critical, because of you're going to use lose your mark if you use your calculator in a wrong way. Now the last thing is to drawing the curve of the titration process. How to draw the curve of the titration process? We have 2 kinds of curves. Look, if we have acid and adding base, if a base is added to the acid, it means we have a medium and we're going to add base. What will happen to the pH? Well, adding base into anything, what will happen? The pH will start rising. So it means increasing of pH. Why increasing of pH? Because we added base to the medium. But what will happen if we add the acid to the base medium, or adding acid to any medium, what will happen? The pH will be decreased. So adding acid to alkaline medium, the pH will decrease. Now we have acid, so the pH will be raised just like that, and in here we have the equivalence point. So we will detect the pH of the equivalence point. I'm going to show you how. Then the pH will be raised until reach to the 40 or below 40. But look, here we have pH for the alkaline medium firstly. So we should start from 40 or below 40. It depends on the question. So it will be decreased. Why? Because we're going to add acid continuously. Until reach to the equivalence point, I'm going to show you how to identify the pH of the equivalence point. Then it will reach to the 0 or near of the 0. It depends on the strength of the acid. Let's see how we can draw this table. How we can draw this table, this figure. Look, draw the curve for the titration of 50 milliliter aqueous solution of HCl with 1 molar aqueous solution of NaOH. Okay, we have HCl, 50 milliliter, and unknown volume of NaOH. It means because of the volume of HCl is known and the volume of NaOH is unknown, so that means we have HCl previously and we added the base. So the unknown volume will be added. It means we are adding base to the acid medium. We are adding base to the acid medium. How we know that? Because of the volume of the base is unknown. But the volume of HCl is known. So first of all, firstly, we have the acid in the conical flask. We have the acid, and then we know the volume of the acid, and then we're going to add the base drop by drop. So that means there will be increasing in pH or decreasing of pH. Of course, teacher, because we're going to add base to the medium, so there will be increasing of pH. Let's see. The volume of NaOH is unknown. It means we add NaOH to the acid, which is HCl. So increasing of pH. NaOH is strong base. HCl is strong base. So the pH will be started from 0 because of its strong acid. Firstly, will be start from 0 and will be reached to 40 because of its strong base. So let's see. This is pH value in here. Here we have 40. Here we have 7. Here we have 0. This is volume. Okay? This is volume. So the volume of NaOH is unknown. So that means we have NaOH in here and we have HCl in here because of the volume is known. So we're going to add base to the acid medium. So what will happen on pH value increasing? But we should know pH start rising from 0 or above 0. Well, because of the acid is strong, so we should start from 0. Like that. And in here, look, here we have equivalence point. So the pH continuously will be raised until reach to what? 14 or below 14? 14. Why? Because of the base is strong. Now the most important thing is the pH of equivalence point. Because of both are strong. So the pH is equal to 7 of the equivalence point. Look. This is pH of equivalence point. pH of equivalence point. Simply. We have acid, so pH begins to rising until reach to the equivalence point to the 7. Why? Because of both are strong. And then again until 240. Another question. Draw the curve for the titration 50 milliliter of 1 molar aqueous solution of CH3COOH. Okay, this is known volume. It means, firstly, we have that one. The known volume will be the first case. The unknown volume will be the second case. It means adding to the medium. With 1 molar concentration of NaOH, we don't know the volume of NaOH. It means we have NaOH in the burette and we have CH3COOH in a flask. So look how it's easy. It's weak acid. It's strong. So pH will be raised or decreased. Teacher, we're going to add base to the medium. So the pH will be raised. Like this. So it will be start from 0 or from 40. From 0, teacher. But exactly from 0 or above 0, teacher. A little more or less above 0 because of it's not strong acid. So the pH is almost 0. It's not 0. It's around 4, 3. Okay? So let's draw the curve for that kind of titration, neutralization process. This is pH. Here we have 40. Here 7. Here 0. It's volume by milliliter, whatever. First time we have acid or base. Because of the volume of the acid is known and the volume of the base is unknown, so we should add base to the medium. There will be raising in pH. Okay, teacher, now I'm sure that we have to start from here, but exactly from 0 or above 0. Because of the acid is weak, so we should start here. Raising, then equivalence point, then until 240 because of it's strong. But what about pH of the equivalence point? Is equal to 7 or above the 7 or below the 7? That's the point. Well, strong base with weak acid. It will be alkaline salt, basic salt. So pH is greater than 7. So here will be pH of the equivalence point. Above 7. You see how it's easy? So I think that's enough about the solving questions of the titration process. And there's nothing new to be learned. I hope you understand it about chapter 4 exactly. بمشي كوتايمن با بندي چوارم هنا تا بندي پێنجەم ئینشاءالله بە تەندروستیەکی باش بۆ ئێوە و بۆ ئێمەش پێتان شاد دەبمەوە تا ئەو کات بە خواتان دەسپێرم خواتان لەگەڵ